So hi everyone, thank you for joining us. I hope you can all see my screen. Today's topic is fixing flaky end-to-end tests in Ruby. So this is me, so the bigger one of the two. I'm heading development over at Macandra. We are a Rails consultancy in Germany. So we build mostly greenfield apps with Ruby, and of course every web developer uses JavaScript these days. We also have a product. This is a long-term support product for old versions of Ruby on Rails. So if you have an old version of Rails, you can buy security patches from us. And so my context is mostly I spend most of my week training young web developers and also develop libraries for our toolchain. So, okay, so what's an end-to-end test? It goes under many different names. It's also called a full-stack integration test, or yes, in Rails, a system test. This is a test where all layers are tested with little or no mocking, and with all layers we mean the database, your models, your controllers, your views, and your JavaScript. And when we build web apps, an E2E test is usually that we control actual web browser like Chrome by a test script, and the test script clicks and types and observes changes of the page that is shown in the browser that we're automating. So I have a short video here for a running example that we will be using. This is Twitter here. I think many of you know it. So I have this short scenario. I want to write a tweet. So I click on the new tweet button and I enter the text for my tweet. And then I press on tweet. And then I see the new tweet on my timeline. This is an example that we will be using a bit in the next slides. So this could be an end-to-end test for this scenario. So I like to use RSpec. So this is a feature spec in RSpec. Here I tell the automated process to navigate to the root page. Then I tell it to click a link with a given label. I can fill in text fields. I can click on a button. Again, I can navigate somewhere else and then have an expectation that the tweet I just entered is actually visible on the page. So I guess that if you've joined this talk that many of you have used this kind of test. This API that we're using here is called Capybara, which is kind of standard in Ruby for browser automation. And if you don't like to use RSpec, there are also so-called system tests in Rails, but they basically work the same. You also use Capybara API and you have a different way of matching your expectations. But other than that, it's the same thing, really. Also, if any of you have questions or you don't know any of the tools that we're talking about, you can just talk into a mic or type into the chat and we'll just pause for a moment and explain. Please don't be shy. I'm happy to explain anything. So what's a flaky test? A flaky test is a test that is mostly green, but sometimes it fails. It's red. And it may only fail on some PCs or maybe only in the afternoon or only when the entire test suite is run, but not when you run a single test. And it can be really frustrating because its failures may be hard to reproduce. So a test is red, but when you rerun it, it's green again. And if you have seen this kind of test, you know that it makes a test suite very frustrating to use. And if you tolerate too many of those, your test suite loses this this property that you can just ask it if my code is okay. And I've seen teams even abandon end-to-end tests altogether because they said, yeah, my end-to-end tests there are just randomly green or red. They're no longer helpful to me. And this is a shame. So I want to help you here. So there are, I think, 3 reasons why end-to-end tests fail randomly. And the randomly is in quotes because it's not really random. And the most important is that you have some kind of uncontrolled concurrency in your test suite. And this is the topic I'm going to talk about today. So what do I mean about uncontrolled concurrency? So basically, when your test is flaky, the most likely reason is that the test tries to interact with the browser while it is still busy with the previous command. So for instance, your test clicks on a button while the browser is still loading content or while it is still hydrating elements. So activating JavaScript. And here I made this picture here, so you can see what kind of threads and processes are active in a typical end-to-end test. So here on the left side is your actual spec. This is the one thing that you're coding. And Capybara opens and controls an actual web browser like Chrome, which has its own scheduling built in JavaScript, in its JavaScript engine. And your Capybara also boots a copy of your Rails server, so the browser has a server to talk to. And there is little to none synchronization happening between these boxes here. So basically what your test script does, it just throws commands at the browser as fast as it can, and it does not care whether or not the browser is still busy with the previous step. And that's a huge source of flaky tests. So you remember the tweet example from earlier. We open the new tweet dialog, and we enter the tweet, and we press the tweet button, and then the tweet appears in our timeline. So we return to the test that we've written, and again, it could look like this. I go to the root page, I click on the link, new tweet, which is supposed to open a dialog to enter a tweet. Then in the dialog, I fill in the tweet text with my first tweet at the text. I click on the tweet button, then I visit my timeline, and then I expect that I can see my new tweet on the timeline. So the question is, does this test have any timing issues? And we'll just reveal the answer here. It actually has a lot of potential timing issue that may cause it to fail. So for instance, it can happen that we click on the new tweet button, but the JavaScript event handler to open the dialog wasn't registered yet. So the button is essentially dead, doesn't do anything. And then the next steps fail. Or we start filling in the form, but the form wasn't even loaded on the screen yet. Or after sending the tweet here, after clicking the button, we immediately navigate away from the current screen. And what browsers do when you navigate away, it just aborts all the pending requests that are still in flight. So we may accidentally, when we do it fast enough, kill our own request that posts the tweet. So we won't see a tweet on the next page. And again, when on the next page, the expectation may be too soon, and we may look for the new tweet before the timeline wasn't loaded. For instance, if the timeline is loaded with a JSON request or something, then we may run an expectation on an empty screen. So just to get you in the mood, and I think a very useful mental model to find these issues is that you always assume that a very malicious person controls the timing of your code. So just think, what is the worst thing that could happen if all the stars align and everything is just so very unfortunate? So for instance, what if the test clicks before the JavaScript is loaded? Or what is if that trivial request that always took 50 milliseconds takes 4 seconds? Or what if you retrieve a DOM element to click on it, and just 1 millisecond before you want to click on it, another JavaScript task removes it from the DOM? And if you want to get better at stabilizing test suite, get into the mindset of assuming that anything that can go wrong will eventually go wrong if the stars align. And the way that we address this is that we get an idea of what are the operations that would fail in parallel if we're unlucky, and we force them into sequence. So we leave no room for unwanted concurrency. And I will give you a few very specific examples in the next slides. But first, let's take a look what kind of synchronization we get from Capybara and Selenium. In particular, I want to find out whether Capybara can observe the browser while it is still busy with a previous task. And so this will be a quiz. So if you have an idea what we see on the screen if we run the code below here, just post it to the chat, or you can also use your mic. Don't be shy. I didn't know most of the things myself until a year ago or so. So in this example here, we visit some page, and that page has a lot of scripts and style sheets and images, so a lot of asynchronous resources. And immediately after we visit the page, we ask the browser, what is the ready state of the document? If you don't know this JavaScript expression here, this is basically an enum that either returns loading, meaning the browser is still busy parsing the HTML, or the HTML hasn't even been received. Interactive means the browser has seen the closing HTML tag. But other resources like images or style sheets may still be loading, or JavaScript. And complete means that all the resources linked from the document have finished loading and everything is done. Okay, so okay, maybe look at the chat if you don't have the window open, maybe in the hamburger menu of your Zoom bar. But basically, we get varying suggestions. Okay, I will solve this. This actually prints complete. So actually, this is very useful. When you visit, Capybara will wait until the HTML is fully parsed and all reference JavaScript CSS and images have been fully loaded. This is very nice. So Bianca, is this Bianca asks, interactive. Interactive means the browser has seen the closing HTML tag. So the HTML tag is the HTML DOM is fully available, but there may still be resource loading. Like maybe there's a large JavaScript that's still loading or executing, or some style sheet hasn't loaded yet. This is the difference between interactive and complete. Okay. Okay. So we're pretty safe when we visit a URL. Then let's take a next look. Okay. So okay. So what is actually waiting for the page to load? This is actually not implemented in Capybara. This is implemented in the bridge between Capybara and your browser. Most likely this is a Chrome driver. So this implements a WebDriver protocol, and this defines different page load strategies. And the default page load strategy is normal, which means that Chrome driver will wait until the load event, and the load event means that all the resources have been loaded. So that's the reason why visit blocks until the load event. You could also, if you really wanted to do it, configure your Capybara so it doesn't wait on initial navigation. For instance, if you want to test the behavior of your page while it's still loading. But usually we are pretty happy with Capybara waiting for everything to be ready. Okay, so round 2 would be a more complicated example. In this case, we have an HTML and it refers to a script called one.js, and that takes 3 seconds to load. So very slow script. And one.js appends a new element called two.js, and that again takes 4 seconds to load. And inside of two.js, there is code that appends a new style sheet called 3.css, and this takes 5 seconds to load. And in 3.css is a style sheet rule that paints the body in the red color. So what happens now if we visit the URL and immediately we ask the browser, what is the color of the body? Do you have any guesses what we get here?
There was also a question, Henning.
Yeah, I will answer it after the round. Okay, so so Eve in the chat asked whether the wait behavior only honors resources that are specified in the head, or can they also be in the body? They can be in the head or body. It doesn't really matter. Just if you mark the only way that a resource will not be waited for is if you explicitly mark it as async. So if you have this async attribute, but if it's anywhere in the HTML, or if it is a deferred script or a module script, then Capybara will wait, or WebDriver will wait. So some people get white, some people get red. So it will actually be red, which is pretty impressive. So when async resources load more resources, those all delay the load event of the browser, and these all extend the time that Capybara or WebDriver will wait for us. Okay, so no problem. So far, everything is fine. So now let's have one more example. We visit one page called menu, and when we ask it for the current URL, then we get menu, and then we click on a link, and that follows a link to a second page called /projects. And then we ask the browser, what is the current URL? So are we still on the menu page, or are we now on the projects page? What do you think? So Eve says it's projects, and Alex is a very wise person. It says if it's an HTML link, then we're on the projects page. Yeah, that's pretty correct. So we are on the projects page, and the ready state is again complete because following a link is also navigation under the WebDriver protocols. So our load strategy will be honored, and the same would be true if we were submitting a form. Okay, so I guess that's the point that Alex tried to make. Modern apps rarely make full page loads anymore. So if we're using tools like React Router or TurboLinks or Unpoly, all your links will be handled by JavaScript. And JavaScript usually fetches new content like JSON or an HTML fragment, and it places it into the existing page. And the browser rarely makes a second page load. It's just changes the existing page again and again. And this pattern is something we call single page apps. You've probably heard of it. And now let's take a look what would happen in a single page application. We have the same example as before. So we are on menu, and we ask it, where are we on menu? And now we click on a projects link, but this time the project links is something that is followed by JavaScript and not by the browser engine itself. So where are we now? Are we still on the menu page, or are we on the projects page? Okay. Okay. So Alex says probably on menu, but it's a bit indeterminate. Yes, I think that's pretty right. There's a very high probability that you will still be on the menu page because your test just goes through those lines in a very fast speed. So the code prints menu, and then the test terminates. And most likely your test will be over before the AJ request to the project route even completes, because your test will probably run much faster than the browser can make a request to the server. So when you click on any link that does asynchronous JavaScript, Chrome driver will not wait for anything ever. So the next test command will run immediately, and it does not care whether the browser is still busy with any prior work. So that means for an app with JavaScript navigation, the page load strategy will only be honored for the very first screen that you visit. And after the first JavaScript interaction, you need to manually synchronize the state of your test with the state of the browser, or those two will be out of sync. And that's a huge source for flaky tests. Okay, so here is the last question in our quiz. Excuse me. So what we do right now is same example. We are on the menu page, and then we click the JavaScript powered links to the projects page, and then we ask the browser, do you see an element for the projects list? Any idea what we would see in this scenario? Earlier we noticed that we are still on the menu page at this point. Yeah. So everyone. So there were some correct answers in the chat. What we now see is first true and then projects. And this is not thanks to Chrome driver, because we already discovered that Chrome driver doesn't really wait before DOM interactions, but Capybara will retry failed DOM lookups. So basically when that selector runs, Capybara does not see an element with that selector, but it retries for a few seconds. So what I made here in this code example is I have on the left is the same spec as before, and on the right is what Capybara does internally. So we visit the URL, and okay, that Capybara navigates to that URL and waits for the load event. Then we ask it for URL, we get the right URL. Then we click on the JavaScript link, and okay, that cannot fail. And when we ask Capybara, is there a project list? Then it says, then it internally sees, no, there is no such link. There's no such list. And it retries and it fails, and it retries and it fails, and it retries and fails, until finally some JavaScript event handler goes through and the element appears, and Capybara will return true here. And that is why when we ask Capybara for the current URL afterwards, it will be on the next location, because the waiting has happened internally here. So this method call here was blocking for a second or two. And only if the element doesn't appear within 2 seconds has CSS returns false. Yeah. So we can use this retry mechanism to synchronize our test script with the browser state. And this is like the first technique that I would recommend if you have issues with flaky tests is try to interleave actions and observations. So after every action, observe its effect before you move on to the next action. So I have an example here. So in this case, I go to the list of projects, and this is an action. And in the next line, I have an observation. I expect that I am on the next page because the next page has this title here, all projects. And at this point, I'm syncing again. So now I know if this line has gone through, my tests and my browser are back in sync. Now I click on a link to create a new project. And now, again, I have an observation. What is the result of the previous action? It is that I may be on a new path here on the new project form. Or that should probably be new project path, sorry. Now I fill in the form here. I fill in the title and a budget, and I click on a button. And so what is the result of the form? Maybe something like a confirmation flash. And again, this syncs my test script with the state of the browser. And this is just such a good habit that whenever you do something, you always follow up with an expectation. And you don't do 5 things, because then just Capybara tries to throw 5 commands at the browser, and the browser does random things depending on your timing. So it doesn't really matter what you use to sync or what kind of observation you use. I use different kinds of observation in my example. For example, we have seen an expectation for the title of the next page, or for the URL of the next page, or maybe we expect some text that is only visible on the next page, or maybe we expect some element with a very specific selector that is only visible on the next page. And this way we always know that we are in sync again. Okay, so does anyone have any questions about this technique of interweaving, of always following actions with an observation? So far, so good. Okay. Basically, what this does is it takes away the room for the browser state and the test script state to run too far away from each other. So you only have this. Basically, they can only diverge by a single line of code, and it cannot be that. It can no longer happen that the test is clicking buttons on the 3rd page while the browser is still busy with loading the 2nd page. This is no longer possible that way, and that takes away a lot of room for concurrency. The retry mechanism is actually pretty advanced in Capybara. This is an example from the README. in Capybara. Capybara looks up a sidebar element. There's an element with the ID sidebar. Then it looks for a headline within that element, and then it makes an expectation for the content of that headline. And if that expectation here fails, Capybara can retry the entire chain. So for instance, maybe there's some async JavaScript still pending that is loading a new sidebar. Capybara will repeat this whole chain of DOM traversal and see if anything changes for up to 2 seconds. Well, this is pretty clever, even if you assign a temporary result to a variable like this. Okay, so if you do this pattern, always action, observation, you're probably a long way into fixing your test suite, but there are some limits. There are things that you cannot fix with retrying. And I will show a few examples. For instance, when you are retrying the wrong thing, and you can retry as long as you want, but it will not help. So in this example, we introduce a new custom element. So this is something that you can do in HTML. You can invent new HTML elements like this. In this case, we want to make an element that when you click on the label, it will open the photo in a lightbox. This is like a kind of modal dialog where the background just goes dark and we see the photo as large as we can. And this is one way that we can implement such a custom element. Basically, this connected callback function is always called whenever element with that tag name goes into the DOM. And the current element is simply this here. And what we do in the callback is we dynamically import some Lightbox library that is too large to have in our default bundle. Then we get the attribute from the element, and then we add the event listener that opens the Lightbox when clicked. And now we have a test here, a small test that uses the Lightbox code above. So we go make a single page navigation to gallery, then click on the label, image 5 in this example, and then we expect to see the Lightbox dialog. So do we have timing issue in this test here? So if writes isn't the issue that we click it too early. Exactly that. It may be that we click too early, because what this import function here does, it loads a new piece of JavaScript, and that needs to go through the network, and that is async work. And while this JavaScript here is loading, Capybara may already click on the link, and the click handler has not been registered yet. So there is this window where the element is already in the DOM and we can interact with it, but it doesn't do anything when clicked. So Capybara will retry, but it retries the expectations, the last line here. It will retry to find the Lightbox dialog element, but it can retry until the sun goes cold, because that will never happen. The thing that we would have needed to retry is we would have needed to retry on, we would have needed to click again, but Capybara will never click again. Capybara will only ever repeat the last command. So if recommends making an attribute that we can use to detect whether the link has been hydrated or whether the JavaScript has run. Yeah, we can do that, but maybe we can simply rearrange the code so this issue goes away entirely. So on the top, we have the broken code where there is this window where the link is there, but it's dead. But on the bottom, what we do here is we immediately register the click handler, and we only wait for the dynamic import inside the click handler. So there is no longer a window where the element is in the DOM, but it has no click handler. And this way, there is no way for Capybara to ever interact with a broken page. So this is something that we can fix in our code, but we cannot fix it with just having Capybara wait longer. So you've asked in the chat whether Capybara waits until the connected callback is finished. Well, it doesn't have to, because the connected callback is just it is run in the same JavaScript task in which the element is attached to the DOM, and you cannot observe like half a JavaScript task. So while JavaScript is running, Capybara will not be able to talk to the browser. So Marco mentioned that there is a window where the click handler isn't registered yet, but it's smaller. I don't think that's the case, Marco. I think that's we get the guarantee from the custom element registry as soon as the Lightbox link is in the DOM. This callback function has run. This is just called synchronously in the same JavaScript task. So there is literally no window where there is an element in the DOM, but the connected callback has not yet run. So there's no way to observe the state anymore. Okay, so maybe one more limitation is Capybara can retry a complex operation. So we've seen this example from the Capybara README, but that only works as long as your operation is like this long chain of Capybara commands. So you get some object from Capybara and you call more method on it and call more method on it. This way, Capybara can retry the entire chain. But when you restart the chain in the middle of an operation, Capybara can only retry the last link. So what we do here, we made a bad implementation of the fill-in method from Capybara, where we want to find a label, an input by its label, and then set a value. And what we do here is we manually resolve the connection between the label and the inputs, and we make a second find for the input element down here. And when we restart the find, we start a new chain for Capybara, and we would never retry the find above this. So don't do it like this. Just use fill in. Just had to use some example that is broken. But basically, when you want to retry an entire chain, it must be a chain of Capybara objects calling more method on the previously returned object. You cannot interrupt it and restart it with a new find. And also, and this is an example from a real project that I had, retrying will not help you when your server is just slower to react than your waiting interval. So for instance, this is from a project where there was a form to save a photo, and this form would sometimes not work. I had this expectation here that the image was uploaded successfully, and sometimes I would not get this text. And the reason why it sometimes did not get this text is that there was some very heavy post-processing on the backend. So whenever we uploaded a photo, we would synchronously create a very large version of it using a carrier wave uploader. And sometimes this took more than the 2 or 3 seconds that were configured for Capybara to wait. So my colleagues did not have the issue, and the reason was that they all had the fancy desktop machines with the 100 CPUs, and I only had my slowest notebook. So it would only happen on my machine. And when we wait, we always need to wait long enough for the slowest PC that we have on our team or on your CI server or whatever runs your tests. The slowest machine must have enough time to wait. And even if you have a very fast PC, it is probably slow when you run parallel tests on all your CPUs. So we must be generous with our timeouts. Basically, you can configure this globally in Capybara, or you can configure this in every matcher. Has a wait option Capybara, and you can tell it to wait for 10 seconds if you want. That should be enough time. But we ended up solving this differently, because we realized that this test does not care about the post-processing. So it was just a side effect that this broke our test, but this test did not care about this version here. So what we ended up doing is just disable, giving us a way to disable this feature. And so we disable this in the test. And this way, the issue went away entirely. And of course, the test runtime just went down from 10 seconds to 1 second. And this is the second pattern that I would encourage you to explore is that you avoid testing a specific class of features that has a lot of side effects, because they introduce uncontrolled concurrency into your E2E tests. And these are features like lazy loading images, or autocomplete in search fields, or live form validations, or maybe some mechanism that locks a form against multiple people editing the same thing. Or the example that we heard earlier was post-processing of file attachments, or maybe some polling implementation that makes sure an element is always kept up to date, or animations. So what all these things have in common is there is probably only 1 or 2 tests in your test suite that actually test for these things. But every other test that also uses the same screens are also suffering from the concurrency issues introduced by these features. And what I would encourage you to explore is to disable all of that by default and use feature flags to only enable them on a 1-by-1 basis for the one test that actually tested. And this will increase the stability and speed of the test suite. And I will give maybe a few more examples. Why are these kinds of features an issue? What is it about them that they introduce this randomness into your E2E tests? Okay, maybe I will give a specific example how to implement a feature flag later. So, for instance, lazy loading. Lazy loading is a technique where we don't load images when we get the HTML, but we wait until the user has scrolled down a bit, and just before the image is visible in the viewport, the browser loads the image. And that's a performance optimization that you can use, and it's usually a good idea. And so we had a project with a lot of lazy loading images, and so we had a page with a lot of lazy loading images, and at the end of the page on the bottom there was a link, and the test wanted to click on that link. And what Capybara wanted to do, what Capybara always does before it clicks on a link, it scrolls down the page until the link is visible so it can click on the link. And the scrolling by Capybara triggers the lazy loading of the images that are suddenly visible. And sometimes the images would load very, very quickly. And when an image pops in, the layout shifts to make space for that image. And so what sometimes happened is that Capybara clicked on the wrong pixel position because it scrolled the page, and by scrolling the page, all the positions of the elements changed. And the link was never followed. And the expectation for the next screen would fail because we never left the first screen. And of course, that did not happen all the time. It just happens like some of the time, and maybe on a small machine, on a slow machine. It's just the kind of thing that makes an annoying flaky test. And the scenario that was tested did not care at all about any images. It did not test images, it did not care that there are images. It's just that there happened to be some images, and the test became more unstable by the synchronization issues introduced by lazy loading. Maybe one more example. So we had a polling implementation where some element was periodically reloaded from the server every 5 seconds or so to get it up to date with the latest server-side data. And so sometimes it happened that the test ended right after a polling request was sent, but just before it was received by the server process. And what Capybara does when the test suite terminates is it stops the server process that it booted earlier, And now the browser request failed, and the browser reports a network error, and the test failed because we have a check that makes sure that no JavaScript errors are visible in the console. Again, this scenario did not care about polling or server updates. It just happened to sometimes be read because of it. And that's very unfortunate. So, and all of these examples may seem a little arcane, but this is just the nature of a flaky test. It is something that does not happen all the time. It just happens sometimes. If the goblin in your code just makes sure that the timing is very unfortunate for you. So I have a few more examples. I don't think I'm going to go through all of them, but I could like go on for days how these kind of features introduce flakiness into your test suite. And it basically every slide here took, I don't know, a few days to find out what's even going on. And to sum it up, my recommendation is to use feature flags to selectively enable those features for the very few tests that need them. Here's one way. There are like a million ways to build feature flags, but the simplest way that does not involve additional gems is you have just a bunch of configuration options in your environment. And in this case, I would just disable all the features by default in our test environment. And then I enable those features for the one test that actually cares about lazy loading images, or the one test that cares about polling. So I made an example how we could build this. So this is a very naive and simple polling implementation. Again, we build a new element called autopoll, and what this element does, it fetches this URL every 5 seconds or 10 seconds and replaces its content with the server response. Again, if any questions, just ask. So we don't, okay, I mean, we don't really need to go too far into the implementation here. This is the most naive and simple implementation I could come up with such an element. And what I recommend is give your tests a way to disable features by, for instance, by adding a meta tag to your HTML, which looks like this. Here, meta name, feature polling, content false. And when the component sees a meta tag like this, it's no longer, it stops polling. So how would we build this? Basically, we add another function that checks if this meta tag is in the head. And if its content is false, we consider the feature disabled. And then in our component, we add just this one line in the connected callback that just skips initialization if the feature is disabled. So that's the most simple way to build this without any libraries. Of course, we need to configure our feature flags, and what I would do, I would enable everything by default, so you get it in development and so you get it in production. But in the test environment, I disable everything by default. And then we can just echo the current setting in our head and add a meta tag like this. And now this is either true or false, depending on our setting. Okay, any questions about this technique? Okay, one question that was that whether we can make the slides available. So we make a recording of this talk, and you should have the slides in there. Okay, so this is an example for that one test that actually cares about polling, for example. And in this test, we re-enable the feature just for that one test, and so we can test that polling happens here, but we don't have polling active in all the other tests. So the chat asked whether this technique creates an overload. Can you elaborate what you mean by overload? Do you mean that there are too many feature flags? Sorry, it didn't. Okay, I'm afraid I don't get the question. Yeah.
Yeah, can you hear me? Yeah, I'm asking if this
fine,
will create a extra time, like how much will be the overload in time when you add these flags and you have to keep checking that they're true or false before you continue on loading or not loading the page.
Okay, of course, this requires one DOM lookup here. I mean, it's probably in the nanoseconds. But if you are if this is something that concerns you, maybe one optimization would be to make this check like on the very first line. So this way, if you have 1,000 autopoll elements, you still only pay the cost a single time. But I really wouldn't worry so much about this one DOM lookup taking too much time. So unless you have 1 million autopoll elements on the same screen, you probably won't even notice this. Okay. Again, I'm not suggesting to no longer test stuff like feature or content locking. There's probably stuff that you should test, but I just recommend to not test it when you're not really interested in it. Okay, so one more technique is one way to have fewer end-to-end tests is one way to have fewer flaky end-to-end tests is just by having fewer end-to-end tests in general. So someone in chat says no sound.
I can hear you perfectly.
Okay. So so I'm a big fan of end-to-end tests in general. So these are the only kinds of tests that actually give me the confidence to deploy on a Friday night and just go into the weekend. I can never have this kind of confidence with unit tests, but I'm also a big fan of using end-to-end tests where they make the most sense. And something that has worked very well for us is to aim to only test the most important cases for with an end-to-end test, and push all the other cases into the model where we can test them with unit tests. And a unit test has a much lower risk of leaking because there is rarely concurrency in a unit test, unless you're like working with threads or something, because there is just no second process. In an end-to-end test, we have your test script, and we have the Rails server, and we have the browser, and these are all independent threads and processes that can go out of sync, but nothing can go out of sync easily in a unit test. So for instance, if I have a search, like something you enter a query and then you see the results, then I probably only have a single end-to-end test where the user enters a simple query and only sees matching items. But of course, there is so much more to search on that. For instance, what if the user searches by a prefix? Can I also find a word? Dima, maybe you can rejoin the meeting or something. It seems to be a problem on your side. There's also some menu in the Zoom settings where you can select an audio device, but it seems to, yeah, and Marco also, this is a good suggestion to click on join audio if you haven't already. Okay. So there's much more to search than this here. For instance, can I find a word by its prefix? Or is the search case insensitive? Or what about like advanced search syntax like this, like I'm using Google? Or how do I treat like these non-ASCII characters? Does Märchen with an A match Märchen with an AE? Or do I strip accents when I match a word? What happens when I look for an emoji? Or how can I make sure that the more relevant documents are listed first? There are probably dozens or hundreds of cases that I need to test for search, but I don't need to test all of these with an end-to-end test. I can just have a spec for my search method and make sure that all of this works. And these tests will be much faster, much simpler, and they don't have the concurrency issues of end-to-end tests. I mean, you could write end-to-end tests for all of them, but they would probably just be too expensive to write or maintain. So I recommend to only test the happy path in an end-to-end test. And I also recommend that you take the time to learn some kind of a way to test your front-end code. So for instance, we like to use Jasmine, but there are like a million JavaScript-based test runners, because if you don't have the tools to unit test the front end, you have no other choice than make a heavy end-to-end test for the most trivial front end changes. And as Eve writes in the chat, this just doesn't scale. It's like if you have a large team, or if you're working on the same application for years, you end up with a test suite that takes hours to run, even when you're using parallel tests. So you need to find a way to use the end-to-end tests where they are the most effective. So for instance, to make a look, how does Jasmine, for instance, look like? This is a Jasmine spec for the polling component that I built earlier. And it has this syntax here, which is obviously inspired by RSpec. And so these are just two things that I tested for the sake of an example. I test that the element is reloaded after 10 seconds, and I also test that the element is no longer reloading when it was removed from the DOM. And there are some niceties in Jasmine. You can mock methods, you can mock the time. It's really a nice environment once you get used to it. And of course, it is much faster. So for instance, these two specs here, they run in 0 seconds, while the same test in an end-to-end test with RSpec would probably take many, many seconds to run. Okay, so once we have that unit test in place, the only thing that we need to do in our end-to-end is just make sure that the component is used. For instance, if we have a chat and we want to make sure that the user list is polling, we can just make sure that it has the right element here, in this case, autopoll, and now that's proof enough for me that the polling works. And of course, our test runtime just went down from 11 seconds to a single second. That's a nice benefit also. And also Dima has regained sound here. Okay, so one more tool to share with you today. This is what we call the nuclear option. This is a gem that we wrote. It's called Capybara Lockstep. So what this does is synchronize Capybara commands with client-side JavaScript AJAX requests. When you go back to the start of our slides today, you probably remember that we had all these very nice guarantees. After a visit, then Capybara would wait for everything to be loaded before moving on to the next command. And basically, Capybara Lockstep gives us the same guarantees after every click, after every key press, even when everything is handled by lots of JavaScript. And this greatly improves the stability of any end-to-end test suite, even if that test suite is built really, really badly and has a lot of timing issues. And we built this gem specifically to fix large test suites of legacy applications where we could not go back and apply the action observation pattern to thousands of end-to-end tests. This would have taken months or years. So we needed some way to stabilize the test suite now without changing everything. And so we built this. Okay, this was once again the Twitter example from earlier. On the right, you see what Capybara does. And we again see that whenever we interact with the DOM, Capybara fails a lot internally and retries and retries and retries. And we also discovered that there are some cases where we cannot fix it with retries. For instance, when we navigate away and abort all pending AJAX requests, and then Capybara times out and your test fails. So when we run the same spec here with Capybara Lockstep, it looks like this. So we wizard a page and Capybara Lockstep automatically waits for all resources to load. Then we click on a link and again, Capybara Lockstep automatically syncs. And you see that whenever we do any kind of input, Capybara Lockstep synchronizes, make sure that there are no pending AJAX requests, that there are no pending scripts to load, no pending images to load, and so on. And you see that it makes Capybara's internal work much calmer. So there's no longer this aspect of like smashing Capybara's head against the wall until it maybe works. And of course, Capybara's retry mechanism is still there, but now it's a secondary safety mechanism for cases where Capybara Lockstep misses some async work. So if asks if the request is sent, it would be still processed by the backend, right? So that itself has timing problems. Yeah, if it is sent, it will probably be processed by the backend, and then there's probably a timing issue whether then you have two requests at the same time. You have one request from your from this here and a second request here, and one will just respond earlier. Okay, I don't know if it can be aborted before it is sent. It probably depends on your AJAX request mechanism. So if you have some kind of like, if you only wait for a single JavaScript task for some reason, then there's a window where you can navigate away before the request is sent. Okay, so here are some guarantees that Capybara Lockstep gives you. So it's whenever Capybara simulates a user interaction like typing, like clicking, Capybara Lockstep synchronizes, or when Capybara visits an URL, or when Capybara executes JavaScript. And whenever it's synchronized, it will wait for all document resources to load. And it will wait for all client JavaScript to render or hydrate DOM elements. It will wait for all AJAX requests to finish and their callbacks to be called. And it will also wait for inserted script, image, or iframe elements to load. So in summary, with Capybara Lockstep, it is basically impossible to observe the page while any HTTP requests are in flight. And this covers most async work that causes flaky tests. So if you are in this situation where you have this legacy test suite like I had, maybe that's a solution for you. You can also like signal additional async work if you do some async work that does not result in a network request. Capybara Lockstep cannot see it, but then you can just tell it that you start some work, where it started, where it stops. And this way you can just hook it into everything, but it will perform very well out of the box without any hooks or configuration. Okay, this is how we install it. Okay, just maybe to give you an idea how this works, I can just show how you would install this. So I have this very basic CRUD application here, and I install Capybara Lockstep here. Probably need to bundle. Okay, so I got this thing, and now I have to add a single tag into my layout for Lockstep. We can also, I will activate debug so we can see something. When I now start the server, we should already see it working. So basically, this is a very simple CRUD application. Everything here on the top is an AJAX request. And if you take a look at the console here, you see how Capybara Lockstep is detecting work. And whenever it's in the red, your test would no longer be able to talk to the browser while it is synchronizing. And this would also have work if. So now I'm inserting an image, and you see how it detected that an image was being loaded, and here it detects that the image was done loading. So it's really simple, really easy to integrate. So there was a question in the chat whether adding Capybara Lockstep would make your tests run longer. This was actually a very big concern, that we would make our tests slower because our tests are already too slow. And basically it ended up making the tests about 10% faster. And this was just because we would no longer retry so much. So basically in the end, we had multiple levels of retrying. First, of course, we had Capybara configured with large timeouts. And then because we had so many flaky tests, we had Cucumber configured in a way that it would rerun failed tests after test run. So we would retry failed tests up to 2 times when it failed. And so because we no longer had to rerun entire tests, we ended up with a faster test suite than before. But even if you have, if you don't have to do this because your test suite is better than ours, I wouldn't worry so much about the performance. It's really, so it was a main focus of the implementation was that it did not add too much performance cost to your test suite, because that's the main concern that we have. But of course, try it in your application. Okay, so this is the last technique or mental model I want to share today. This is what I call the flakiness balance. So when I see an application that has issues with flaky tests, then I build something like this in my head. So basically, there are some factors of your implementation in your tests that introduce more concurrency issues into your test suite. For instance, if you have any kind of async JavaScript, or if you're using a single page app framework, you immediately increase your risk of having flaky tests. Or if you have animations, you increase your risk of flaky tests, so disable those. If your PC is slow, if you're running parallel tests, you will increase the risk of flaky tests. But then you have some techniques that also fix those flakiness issues, and they, by synchronizing operations, by removing space for concurrency. For instance, if you run in the headless browser, that's a positive effect on your flakiness balance. Or Capybara's retry mechanism is very helpful. Capybara Lockstep is very helpful. We learned this technique of interweaving actions and observations. That's very helpful. And of course, then there's also something that you don't know. So it's never like a perfect balance or something. And also I made up all these numbers by gut feeling. But essentially, the range that comes out should be more on the positive. And I just know that when I introduce enough of these tools and patterns that take away space for concurrency, the issue will eventually go away. And this is how I approach stabilizing legacy test suite that I cannot rewrite because it's just too large. All right. So basically that's everything I wanted to tell you today. These are the techniques that I encourage you to check out. Assume that an evil creature controls the timing of your tests, and always assume that things will work in the worst possible order. Get into the habit of interleaving actions and observations. Consider disabling problematic functionality with feature flags. Consider just having Fury end-to-end tests and pushing more work into unit tests while still keeping a few end-to-end tests around. Use tools like Capybara Lockstep, and also keep your flakiness balance positive. All right. So this is everything I had prepared for today. Have a good day.